This is structural analysis and modeling portal section approximate methods of analysis of a 2D frame under lateral loads. GSA tutorial part. For this tutorial, you should be able to learn how to build simple frame and define load cases for lateral loads in GSA. So first of all, let's create a new file and populate the relevant info. In our case, that will be structure, analysis, and modeling portal. And the subtitle can be the name of the section, Approximate. Method of analysis of a 2D frame under lateral loads. Here on next, structure type, we can still use space. Unit, you should select kilonewton-meter, which is recommended. So be aware of the unit length small, because that's used to describe the cross-section size. The stress, if you're confused about the Newton per square millimeters, you can change it to the megapascal. That's okay. Then we click on generate data from the selected structure type. Because the structure we are going to build is very simple, so we can use these functions to do that. So click on the portal frame, input the value of the bay width, which is 5 meters, and story height 3 meters, number of bay 2, number of story 2, columns. So we need the material of the concrete long-term. So the cross-section type is rectangular. Go to next, and period of the unit is millimeters. So we need the columns. Cross-section is 500 millimeters by 500 millimeters. So input 500 by 500 in depth and width. So we go to the beams. Is the same thing. We choose material as concrete long-term, rectangular. Here is 500 millimeter by 500 millimeter. Next. Then we also need to include the supports. So it will generate the fixed support or cast support at the bottom of each ground floor column. And we don't need to include the self-weight in these cases, because we will ignore this part. But in the actual design for some actual building or some other structure, it's recommended you select this one, so you don't need to do the math of the self-weight by yourself. So click on next and finish. Then you can see the portal frame here. So the first thing from here is to conduct the visual check, which first display the support, which is use the label restraints from the right hand toolbars, and see that the knot, which you can open the label knot number, knot 1, 2, 3 is in cast. Okay, then we can check the sequence of this knot, which should be the same as the one we used. We showed in the GSA tutorial handout. Okay, they are same. 1. Okay. So then we can display the element number. Okay. Then we display the cross section. So that's how it looks like. Right now the cross section size of the columns and the beams are the same, so you can't tell much difference. But if they are not, you can see that from here. Easy example to show that is if I change the beam size to 7. So let's have a look. So you can see that the beams has changed. The height of the beams has changed to 700. Right? Okay, so that's how you check whether you have defined the right property. Then we go to the Y elevation and turn all these off. After that, we need to define relevant load case, which is go to the gateway menu, cases and tasks, load case specification, and case 1, we use wizard, and import the name as here, Lateral analysis, and case type will be earthquake, and press OK. Then we need to create the node loading, so we can first turn on the label nodes number, and be aware that actually there are 2 ways to do that. The first way is we know we want to apply the load on node 4 and node 7, so the first way to do that is go to the loadings on the gateway menu, node loading, node load. So select the first line, right click, wizard. So give it a name as, for example, lateral load, and not least there will be node 4 according to the table 2 at the end of the handout. So there will be 25 kilonewton. That's okay. Then we can define another case for 2, and the list is 7, so the value will be 50. Okay, then we can go to graphic view and turn the all load diagram on. You can see there's 2 arrows. Apply on 4 and 7. So we can click on select for animation from the left hand toolbars and check the value. So another way to do that is to, let's go back. For node 7, you can use select node and select node 7. Right click, create node loading, create node nodes. So we popular name is lateral nodes 2, and it has already selected the node list, so it's very convenient, especially when you are building a very massive structure and you don't want to remember every node. So load case is load case 1, direction is X, value is 50. Okay, so that's the 2 ways to do the node loading definition. Then please note here that when I import the node loadings from the gateway menus, I first check that the node 4 is the same location as the node 4 showed in here, showed in the handout. So if here become node 4, here become node 7, you should change the value correspondingly. Then we can, after defining the portal frame and define the load cases, we can start to analyze this portal frame by click on Analyze All from the top toolbar. And after the analyze, we can close these stuffs and view the deformed shape. So click on the deformed image from the right hand toolbar so we can see how the structure behave under the load cases. Okay. Then we can see the shear diagrams, which is from the FZ shear force diagrams. So you can see the shear force of each element. So our view is actual value. We can select for animation and select them all. And close the loads. We can see how the value is. Then we can check the bending moment diagram from the MYY bending moment diagrams from the right hand toolbars. Also select them all by click on the select for animation. You can check the value. Then sometimes if you feel the size is too small or too big, you can increase it by click on double size diagram, or if you feel it's too small or too big, you can click on half size of diagram. You can open different kind of diagrams. Meanwhile, we also need to check the axial load, which is click on the X axial force diagram, so we can also see its value. Okay. So if too big, we can make it smaller. Too small, we can make it bigger. Okay. Then we need to obtain the support reactions, which is click on the control settings from the right hand toolbar and go to nodal result reactions and FZ reactions. You also need to click on the control based on actual value. So here you see this node. You can refer to the colors here, which is minus 23 kilonewton. Here should be 22.83. So you can also use the select for animation to select them. So you can see here is 23.14, here is 22.83. There's a very small value of here. And then you can record this data and compare to those you have obtained via hand calculations of the portal method. Okay, that will be all for the GSA tutorial part of the approximate methods of analysis of a 2D frame under lateral load section.